have the shower here, the eye wash. Here we never use gas in organic chemistry. In terms of, there's a fire blanket over there in that corner. When we dispose of stuff, or there's the fire extinguisher, when we dispose of stuff, nothing that has glass in it or point or needles should be in here. We could put them in this box. And I also have, it's okay, I also have these bottles. We put more of them out. The water jar that we put, as you can see, the Sharpies. What is preferred, some of these are not bent, but when you go dispose of a needle, you should bend it and then put it in there. Notice that we don't have any glass in this one. We could have separate jugs. So we have a lot of jugs down there where we put some for needles specifically and some for glassware like pipettes. Or some of our operation will involve using pipettes, which are glass. So for example, when we use this instrument, which is an IR instrument, we use pipettes, not syringes, okay? And these can go in that one box over there, when you're disposing of them, or in milk jars. All right. I think that's pretty much for the safety around here. If there are other things, as I remember it, I'll let you know. So,
as someone's bleeding out on the floor,
is go through step by step, perhaps, what someone would be typically doing in setting up a reaction all the way to trying to isolate your product. So I'm going to try to do the entire process. Of course, some of you are going to do different things. Some are going to do extractions. How many persons know in your procedure that they were doing extractions? It would say extract with ethyl acetate, blah, blah, blah. How many persons are going to be doing filtration to collect a solid product? Okay, so we'll cover all of those. But to begin with, you're going to want to set up your experiment. The experiments are going to be set up in the hoods. Along the sides there are the hoods. The same thing in your next
hood.
And we'll show you some of that, how to use that as well, because you notice right now some of the windows, what we call sashes are up and some are down. It's best when it's not being used to have them all the way pulled down, otherwise it creates a vacuum. So this is what I'm talking about. These, when you finish using it, as much as possible, pull them down, keep them down. Because you would notice, and we can do that experiment sometime when we want to have some fun, is pull them all up and then try to get through that door. It's pretty difficult. It has very high pressure. Okay, so we'll be working in there, and we're going to set up reactions. Okay, so what we want to do is set up a reaction. In all cases, every one of you are going to be using a round bottom flask. We have round bottom flasks, and they should be in your drawer of different sizes. And of course, the size you choose is probably determined by what I told you, and maybe also by, so you have different sizes. 25, 50, 100, 250, and 500. And we could get higher than that as well. So one of the first things we want to do is, of course, make sure that the glassware is clean. What you don't want to do is clean your glassware, and cleaning glassware involves water, either from the squeeze bottle or from the tap, and then acetone to clean it out as well. But you don't want to take that after you clean it with water and acetone. You always want to clean it last with acetone and immediately start putting stuff in. So it's always best to have clean, dry, round bottom flasks that are ready to go. So you don't have to waste 10 or 15 minutes washing it with water, acetone, and then putting it in this oven. We have ovens in both labs here, and you can see we have some pieces of equipment here, but this is where, when you clean, you may have to use soap in some instances, soap, water, acetone, and you're ready to get it dry, you put it in here. I would say if you need to use it right away, maybe 15 minutes, 10 to 15 minutes in this oven. The oven is already hot at the right temperature. And you have to kind of snap this oven like this. Okay? Just snap it, shut like that. If you just do like this, it's going to remain open. Okay, so you have to put some pressure. So, yeah, there's a lot of reactions that if there is water or any other thing in here, it's going to mess up the reaction. So clean, dry glassware. If you don't have it immediately, you have to wash clean, water, acetone, dry for between 10 to 15 minutes before you use it. Okay, so assume that this is clean, dry. The first thing, and one of the most important things in doing a lot of these reactions with glassware is always, no matter what glassware it is, secure the glassware with clamps. And so there are different ways of setting this up. You could do it like this, for example. Or sometimes you could put this. This is a hot plate stirrer. You could put that on top of here and then put the glassware on it. But whichever way you come up with is fine. We have different stir bars because one of the things we want to do is make sure that the reaction mixture is being stirred. Again, we have different sizes. Most of the time we don't use this. Maybe Jaden might use it because he's going to do a large scale reaction right off the bat. For most of you, maybe this size or a little bigger will work here. So again, make sure it's clean, dry, put that in. What you would notice is that there is in fact, so I'll show you. So this is the heat, this is the stir.
Amazing. Okay?
So we have those two controls there. I'm just going to turn on the stirrer, and the magnet starts spinning. And that's simply because there is, in fact, a magnet right in here. And you can see this thing spinning for you guys that are closer. See that stuff spinning? That's a spinning magnet in there. Okay? So that's how we're going to stir. We are not going to take, your time with a glass rod or whatever and just stand up here for an hour or 2 hours stirring. This is going to stir for you. This one has the ability to stir and heat. Now, there are some cases when you're doing reactions where heat is not required, like you don't have to do a reflux. Reflux always involves heat. If you're doing something at room temperature or a reaction at in an ice bath, and I'll show you how to do the ice bath here pretty soon. How many persons doing an ice bath? Okay, yeah, I'm going to have to show that to you. This one, these types here, do not heat. And so if you're doing something that does not involve reflux or heating of any type, you're going to want to use these. Just because it's going to free up more of these for those who need to do the reflux. This also operates the same way. It has a magnet that spins in the air, but this one doesn't heat this type. To do a ice bath, we go over here to the ice machine. You guys knew we had an ice machine?
Yes.
Okay, so I'm going to the ice machine. That's some ice. Okay, you can fill it up with ice. There's the ice machine. It has this here too if you want, but you could just do that. Okay, ice machine.
Make an excellent subject for a documentary.
This is not
The elusive Desmond Murray on the loose.
ice bath. Everybody pay attention. This is not an ice bath. This is just ice. Okay? An ice bath involves filling this up like so with water. Now we have an ice bath.
Amazing.
Water and ice. So if you were to do a reaction with an ice bath, you do like this, and then you immerse. You could try to get it as deep as possible. There's your reaction that's going to go in an ice bath. Okay? Now, most of you will be doing, but before I go to reflux, one of the other things that you guys need to do, some of you, most of you I think, is to make, is to use a drying tube. Anybody remembers in their procedure having to use a drying tube? This is a drying tube. Okay? And just before I show you how to make it up, because it's not made up yet, is that it fits right here like this. Do not ever do this, because we're trying to keep moisture and stuff out. That's the whole purpose of a drying tube, and this is not going to do that. You have to use, this is more precisely called a thermometer adapter, but we improvise. It is an adapter and allows us to fit the drying tube like so. But this is just the skeleton of it, really. In order for us to have a real drying tube, what we need to have is drying agent. And the drying agent that we're going to use is calcium chloride pellets. And to make up the drying tube, you could see that the drying tube consists of this part and then these two ends. So we take cotton or wool, glass wool, and we stopper just a small amount to stopper both ends so that the calcium chloride doesn't flow through. And then put one in, like so. You could do this now in multiple ways. You could take, maybe the safest way is to take a funnel and then pour it in. That's probably the easiest, safest way. Here we go. Now you got your calcium chloride drying tube. And once you make this up for one experiment, you're pretty much set with your drying tube for the entire semester, unless, you know, you put this into like water and stuff. Could happen. So this is your drying tube. Everybody sees how to make it. We have lots of calcium chloride around. That's not the only amount. And then you can put that on there.